Welcome to the first video this week on legacy software, architecture recovery, and change. To start us off, we're going to talk about what the term legacy code actually means and why it is actually very normal and not the end of the world. So legacy code, there's sort of like a saying here, right? Legacy code is code without tests. That isn't always necessarily true, but it is a nice place to start. Because what we're saying is that legacy code isn't inherently bad. We don't necessarily know that the quality is bad. Legacy code is code that's difficult to maintain. It's difficult for us to now work with in today's landscape. That's really what legacy code refers to. So it's perfectly normal. Software will age naturally. Environments change, tools change, the needs of a company and software and its clientele are going to evolve. So long-lived systems will inevitably become legacy at some point in time. That's just what happens. Rewriting this code base, this system from scratch, often feels very risky if it's been set up for a very long time, and with that, quite expensive. And legacy code is often represents this sort of environment where we have valuable domain knowledge just baked right into it. And we'll sort of explain what that means in just a second when we talk about where we often find legacy code. Now, like I said, legacy code isn't inherently bad. Legacy code can be brilliant, really well written, battle tested, but it's old, right? It was written in an outdated language or a framework that is no longer being maintained and supported. It could have no documentation or parts of it are undocumented. It could have missing context, so we don't understand how all the pieces are working together. And sometimes there are no active maintainers. It's code that just sort of lives there and sits there. And the team has moved on, maybe to different companies, maybe just to different projects, but nobody's actively working on that code and hasn't in a while. So business critical systems are honestly often legacy, and they can work flawlessly. They work beautifully. Nobody wants to touch it. It's good. If it ain't broke, don't touch it, right? Legacy is more of a signal that the maintenance context for this product, for this code base has changed, not that the code itself is inherently poor. And again, this might mean that design patterns used are outdated. So maybe we do look at it and we feel like, oh, this is really poorly written code. But in of itself, legacy code isn't necessarily code of poor quality. So like I said, I would tell you a little bit more about what it meant for code to be valuable, to have valuable domain knowledge baked in. Here's what we're talking about. There are a lot of very real, alive, functional legacy systems out in the real world. Many banking software systems, medical software systems, aviation systems, and government technology rely on legacy code to function. And why is this the case? It's because of that valuable domain knowledge. Somebody smart in the banking world or in the medical field or in aerospace came along and helped design this initial system, and it works beautifully. And then they died or they moved on, right? Hopefully they just moved on. But point being, they retired. These people didn't stay in their job for their whole entire life forever. They moved on to do other things. And so these systems that heavily rely on core functionality like payment processing or the way dates are handled within a banking system or how medicine is being administered through automatic machinery or the metrics that are being taken when an airplane needs to land, those like critical systems and critical information about the domain is already baked into this system, and then those people disappeared who made it. So that's it. They're legacy systems now. To try and change this without the same clarity of understanding as the individual who created it makes it risky, makes it harder to maintain, makes it a legacy system. So like I said, we have this challenge with legacy code, right? We're scared to break it, especially if there's no tests. We're terrified to try to change legacy code because what if we change it and now we break it and we don't know what happened, right? We end up in this mentality of it ain't broke, don't touch it, just leave it alone. And this also makes it hard for us to even refactor. So not even just talk about like adding features, but refactoring legacy code. There could be tight coupling or dependencies sort of enmeshed on each other and we don't know why. There might be the use of outdated patterns or like language features that are now deprecated that make it hard for us to do refactoring to make it maintainable. And all of this, coupled with the lack of documentation or context that we might just not have, makes this really challenging to work with, right? If we don't have a ton of knowledge transfer, if the original authors are no longer reachable for whatever reason, we find ourselves in a really tricky position. So we end up with this confidence gap. We have developers who are now hesitant to make improvements because they don't understand the impact. And again, when we talk about in those systems, like banking systems, in the medical profession, right? Not understanding the impact, making a change and not understanding the impact can kill people, right? Like the changes we make can affect people in ways that we can't even begin to comprehend. And that is terrifying. And it's okay that it's terrifying. It should be. It should worry you that you may try to do something and break a critical part of a system that has been, working function free with no problems. So how do we interact with legacy code if we're terrified to touch it, if we have this confidence gap? Well, big rewrites are a very high risk. We need to first understand that if we come into a system, we need to shift our mindset. We cannot come in and say, well, we can fix this whole product if we just code for 12 hours and get it all done at once, right? Big rewrites are a high risk. I see this in group projects every single year where somebody the night before the due date says, I can make this better. Let me just go and rewrite this entire service. And they crash the whole team's project. I have seen this happen more than once in this course, right? You think you want to be the hero, that you'll be able to do this, but maybe there are unknown dependencies that you weren't aware of, or there's hidden business logic that you didn't quite come across, right? There is so many reasons why a big rewrite is a bad idea, including deadlines coming up, right? Or running out of money. So you start with a big rewrite and then nothing actually gets done because you ran out of money before anything could be completed. Legacy code's value is in the fact that it already does the job. It has been living as it is in the state that it's in, functionally and correctly for some period of time. So instead, when we want to make these changes in a legacy system, we need to favor these small, safe changes first. The very first thing we should be doing is adding tests. So before you do anything in a legacy system, you need to be able to add tests to the system, to the part of the system you're working with, to make sure you're not going to break the functionality that already exists. So if tests aren't there, job one is to add them. Once you've done that, you can start to tackle one module or function at a time, where we're peeling off that module or function, we're getting a good understanding for it, and we can validate each of our changes before we move on to somewhere else. We really want to make sure that we have a good, solid, confident feeling that the work we've done did not break anything before we go on to try and change something else. We really need to embrace this idea of incremental or iterative understanding. We are going to learn the system by working with it, by going through it and sort of slowly integrating ourselves into it and peeling back the layers of a legacy system, especially a complicated one. We really need to think about it like peeling back layers one by one. We should be asking ourselves, what's the smallest improvement I can make today? Not how can I make this whole thing bigger right now, right? Like how can we fix the whole system? It's also incredibly important that when working with these systems, we take the time to document as we go. Because in the future, if you have to come back to this project again in 6 months, heck, 3 months, future you will thank you for documenting what you've changed, how it worked before, how it works now, what we know works, what else needs to be done. All of that good stuff can be documented and will save you time in the future. So at this point in the video, we're just going to go into our own projects and find any class that lacks tests and or documentation, right? If somebody else were to join your team right now, would they call this legacy code? It's possible if they'd come in and they have no idea what these methods do, how they connect to each other, how they run, what testing has been done, what confidence level there is in your code base, right? That might be legacy. So how could we actually ensure for our future selves that we know what we did in our project? Let me tell you, I can look back on my software engineering Comp 3350 project from many, many years ago, and I have no idea what any of it is because we have no documentation. We have documentation to get it up and running, but none of the code has like comments in it. So I look at a class and I'm like, I don't actually know what this class talks to or what it does. And boy, does it make it harder to follow through and understand. So go take that minute with your projects, see if you can figure out what the heck is going on with your projects. Maybe you'll end up adding some tests or documentation. And then I will see you in the next video where we continue to discuss legacy code and sort of following along in in legacy architecture. Thanks. Bye.